You know how to transform a parallel programming problem into a sequential problem? Well, neither do I. I'm bored. Let's try reasoning on this then. So, I'm building a metal 3D printer at work, and one of the problems I've run into is how the motors that run the X and Y axes must run in synchrony. Otherwise, we can't make any movements on diagonals reliably. I'm programming it on an Arduino as it's just a prototype, and Arduino has a single core CPU, which means there are no threads. That's better. To parallelize our routines. So, after a couple of days trying different approaches, which totally were flawless and caused no stress at all, I came up with a solution. Well, almost a solution. Let's say you want to move the head of the printer from point A to point B. You could move it horizontally until you reach the x coordinate of point B, and then vertically until you reached the x coordinate of point B. But let's say you want to go in a straight line, or even in a squiggly path. Well, to approach that problem, we could get the x distance and y distance, get their proportions, and set the speed of each motor proportionate to that distance. The problem with that approach is that we are using stepper motors. The way stepper motors work is by telling them to step. So you tell them to make a tiny turn, which is given in the case of our motors by 1.8 degrees, and it's going to take that step. If you want it to rotate more, you need to tell it to rotate again and again. We don't really set a speed, so this approach is not optimal. What we can do is step the X motor, then the Y motor, one at a time. Let's see how we can do this approach. Let's get an X and a Y motors and a head. We need to move the X motor to the X objective position and the Y motor to the Y objective position. If we have a 45-degree path, then it's easy. We just take one tiny step in X, one tiny step in Y, and repeat that process until we get to our destination. The problem with that approach is that if we don't have a 45-degree angle, like this, we would need to have bigger steps in X than in Y, like this. Since the motors are the same model, their steps are the same size, which wouldn't work. So we came into a different approach. We are creating abstracts called buffers for each motor. These buffers are like loading bars. We put these buffers into a loop, and with each iteration of this loop, we increment those buffers by the by a value that's proportionate to the distance that they need to travel. So the motors that need to walk greater distances are going to have greater increments in each iteration of the loop. These buffers are ranged from 0 to 1. The motor only takes a step when its buffer reaches past 1. So let's see an example where x needs to walk at a great distance while y needs to walk a smaller distance. In this case, in the first iteration of the loop, we would add more to x and less to y. Notice that neither one of the motors moved, because neither one of the buffers have reached 1. Let's run the next iteration of the loop. Again, none of the motors have moved. Now the next iteration. Notice that the x buffer has now reached past 1, which means it needs to take a step. Now, if we don't decrease the x buffer, then it's going to be always greater than 1, which means it's going to take a step every iteration of the loop, and we don't want that. So we need to decrease that buffer so it doesn't go into an infinite loop of always walking. Now, y has to be increased. Since y is now above 1, it also needs to move. Then the next iteration of the loop, this time, both buffers reached past 1, which means we decreased both of them by 1, and both of them take 1 step. By doing this approach, we have now been able to walk different distances with x and y, reaching the destination at the same time. This is analogous to giving both motors clocks, but these clocks run at different speeds for each one of those motors. We're telling each one of the motors, every second you must take 1 step. The thing is, each clock we gave to each motor has a different speed, so they are both walking with every second, it's just that the perception of seconds to each motor is different. These clocks are our buffers. They are incremented by the same amount each time, just like clocks with its seconds. Thank you for watching.